Electrolysis is an important chemical process. It's used to generate an awful lot of products that are used in everyday life. We're going to have a look today at the electrolysis of brine, which is a sodium chloride solution. This is a very important industrial process as one of the products is chlorine, and this is used in the manufacture of a large number of plastics, but most importantly it's used also in the disinfection of water, and this is one of the most major advances in public health treatment. What we're going to do today is look at the practical that most people have come across in schools, which is often found in textbooks, and that's using a solution of sodium chloride to which we add some universal indicator, and then we look at the changes at the electrodes as we pass an electrical current through it. When we add the universal indicator to our solution, we should get a pH of about 7, so depending on your universal indicator, that will give you a green colour. However, be warned that if you use distilled water to make this up, then you may find that the colour indicates that it's an acid and it goes reddy orange colour. This is because distilled water itself is a weak solution of carbonic acid, which absorbs carbon dioxide from the air. So we've added 2 or 3 spatulafuls of sodium chloride into 75 ml of water in a 100 ml beaker. And what we're going to add is a couple of drops of universal indicator solution, enough to give us a decent colour, but not so much that we can't actually see through the solution. And we're going to give that a quick stir. Okay, so now we've got our solution of brine with our universal indicator. I'm going to put my safety glasses on, and then we're going to put our electrodes into the solution. We're then going to have this at around 10 volts, and we're going to turn the power pack on. What we're looking for is the production of gas at the 2 electrodes, and we're also looking for a potential colour change in the solution as well. Okay, so in the solution you can see that we've got a blue colour around the negative electrode, and we can trace that back to the negative terminal on here, and we're getting a red colour which is starting to also go colourless in solution around the positive terminal. We're producing 2 gases in here. We're producing hydrogen gas, which is coming out at the negative electrode, and we're getting a chlorine gas being produced at the positive electrode. Students find this quite difficult. This is a difficult area of chemistry because students assume that when you have a sodium chloride solution, you have sodium ions and chloride ions. But actually we also have to take into account the water, which can dissociate into hydrogen ions and hydroxide ions. So the red colour we have around the positive electrode is where chloride ions are giving up 1 electron and becoming chlorine molecules, and they cause the water to become acidic around it as some of the chlorine dissolves in water, and eventually you get some bleaching occur around the electrode as well because it will react with the indicator. So effectively we're producing a solution of sodium hydroxide in here, and this is a third use of this process. As well as generating chlorine for use in disinfection of plastics or hydrogen as a potential fuel, we also have sodium hydroxide left in solution, which is then used as a further industrial chemical. What we're going to do now is look at the electrolysis of copper sulfate solution with carbon electrodes. So we're using a very similar setup to the one that we used with sodium chloride with brine, but this time we're going to use a glass U-tube, which sometimes can help us see the products of electrolysis a bit easier. We've got a solution here of copper sulfate solution, about 0.1 molar solution, and we're going to add that to our U-tube and then connect up our electrodes. So we're using about 75 millilitres or so of copper sulfate solution. And remember that when you finish with this solution, don't pour it down the sink because it's not good for the environment. And then we're going to lower our electrodes in, and again using our power pack, turn on, and then we should start seeing some results at our electrodes. This time what we're looking for is at our electrodes we should see gas being produced at 1 electrode and nothing appearing to happen at the other electrode to start off with. However, if we wait a couple of minutes, then we should be able to see something produced at both electrodes. So what we're seeing here now is we're seeing bubbles at the positive electrode, but initially we can't really see much at the negative electrode until we lift the electrodes out of solution. At the positive electrode we're producing oxygen, and that will actually start to react sometimes with the carbon electrodes to give us carbon dioxide. But that's an approach that's best left for further study rather than trying to deal with that now. So we'll turn the power pack off and then we can lift the electrodes out. And now if we look at the electrodes, we'll see that on the negative electrode, we've got some red deposits, which are pure copper being deposited on the carbon electrode. This process is used for refining copper. And for that, we have a pure copper rod on the negative electrode, and we have impure lump of copper on the positive electrode. And as the reaction happens, the impure gets smaller and pure copper gets deposited on the pure copper wire. And that's used for commercial refining of copper.